Okay, in today's video we're going to be dealing with percent yield, and you might recognize this question because we've already done this one as a limiting reagent problem. In percent yield, all we're doing is a limiting reagent problem and we're adding one step on. So here's what they say. They say when 114 grams of aluminum is mixed with 186 grams of chlorine, 205 grams of aluminum chloride are made. Now, this is your actual yield. Your actual yield is always given in the question. Okay, so what it's saying is you've actually made 205 grams in the lab of aluminum chloride. So let's write down actual. So to get the theoretical yield, we have to go through a limiting reagent problem. So we have to take these masses here and we have to change them into moles. Now I did this in the last video, so I'm going to quickly go through here. And we find that we make 2.11 moles of the aluminum and 0.88 moles of the chlorine gas. Once again, if you're curious as to how I did that, go back to limiting reagents and watch the video. That means that we carry over here and we get 0.88 moles, and then we do moles equals mass times molar mass, and it comes out to approximately 232 grams. This is your theoretical. Theoretical is what you calculate on paper. Actual is what you make in the lab, and it will be given to you in the problem. So, given in problem, calculated on paper. Percent yield equals actual over theoretical times 100. Our actual was 205 grams. Our theoretical was 232 grams. Let's do that. 205 divided by 232 equals, that's 88%. In chemistry, that's a pretty good yield if you get 88% of what you think you should have calculated, because you lose little bits along the way as you're doing the experiment. Maybe you didn't scrape it all out of the beaker, maybe it got caught in the filter paper, maybe when you weighed things off you didn't get all of the reactants into the jar. So 88%, pretty good yield.